Welcome to Million Martian meeting here in Darmstadt. Thank you all for coming. I couldn't imagine at the beginning of planning this event that it is that international. It was supposed to be for Germany only. But now I see people here from Spain, from Netherlands, from UK, Swiss, Austria, Belgium, Poland, France, Mexico, and South Africa. Have I missed anyone?
Norway.
Yeah? Canada. Australia. Norway. Russia. So you see, it's such international, I can't believe it. It's really great. So, and today I am proud to introduce Robert Zubrin of Mars Society here on Skype. Hi, Robert.
Hello.
And Bas Lansdorp, CEO and co-founder of Mars One, to you.
Thank you very much.
You're welcome. We will start with questions for Robert Zubrin, watching the Mars One video, One Way Astronaut, and then talking to Bas. This will be a tough event and a tough timetable until 5 p.m. I'm really grateful for the opportunity to present the first event of the Mars One mission here in Germany and Europe. This is my very first and very short planned event. I want to thank those special people, Marike, Wolfgang, Bas, Esther, Frank, where's Frank? Ah, there's Frank. Stefan and Fabian. Thank you for supporting me. That's an applause. Without you, it wouldn't be possible to have this event, to achieve the first step in our journey to Mars. Thank you. So, now we will start with Robert Zubrin. The first question is for me. How do you feel about cooperating with Mars One? Are there important similarities between Mars Society and Mars One?
Well, I'm in favor of cooperating. Do you have more to the question?
I repeat the question.
No, I think.
Ah, okay, cool. Sorry. So, we will start now with questions from Bas.
Can you hear me, Robert, or do I have to move to the microphone?
I can hear you fine.
Okay.
There was just a question about cooperation. Do you want me to answer it?
Yeah, so I think what Rob is pointing at is how could Mars Society and Mars One cooperate to achieve our common goal of getting humans to Mars?
Well, we should cooperate. We can cooperate in many ways. First of all, just on the level of ideas, in terms of promoting the vision of the importance of the human exploration and settlement of Mars and the transformation of humanity into multi-planet species. In certain ways, simply spreading the idea is the most potent things we can do. But because you can never tell, who the idea will inspire and what they will do afterwards. But there's also things we can do that are very concrete together. And, Mars One, the objective of Mars One is to be living on Mars. And I think it's important to practice this before we actually go there. And the Mars Society has built 2 Mars analog research stations, one in the American desert, one in the Canadian Arctic. We actually, I believe right now, have posted an open call for volunteers to be members of the crew of the Mars Desert Research Station for the upcoming field season. Those are 2-week rotations, in which crews go there, and these are crews of 6, and attempt to conduct a sustained program of field exploration in the desert while operating under as many Mars mission constraints as we can impose within the limits of our resources. But beyond that, we have an Arctic station, which is in a polar desert on Devon Island, 75 degrees north, 1,500 kilometers from the North Pole. It has a year-round average temperature of -50 centigrade, which is the same as Mars. It is in the midst of geology that is very similar to Mars. In fact, it's on the rim of a meteor impact. And we intend to send a crew there for a 1-year mission. We're calling this Mars Arctic 265. We had a refit mission to prepare the station this past summer that was successful. We're going to have another refit mission next July, but directly following that, in August, we intend to hand the station off to an actual crew of 6 people who will live there for a year in this barren desert, attempting to conduct a program of sustained exploration while operating under Mars mission constraints and facing the isolation and stress of the Arctic, which is not as great as that of Mars, but is a major step towards it. And we would like to seek ways to collaborate with Mars One on doing this mission. We want to have Mars One participate, both with people and with money, and with public outreach and other ways. And so Bas is going to be in the United States next week, and hopefully we'll have a chance to sit down and talk about how we might do this. This is my proposal, and I'm open to proposals coming from Mars One on other ways that we can cooperate.
Great, thank you.
Okay.
So, you can have your own question now.
So, Robert, I'm really wondering, as I already told you during our event in Washington, when you were also present via Skype, your book was one of the first things I read when I started designing a Mars mission, and it really inspired me to simplify things. And my big simplification was to eliminate the return mission. Did you ever consider eliminating the return mission and making it a mission of permanent settlement?
Yeah. In fact, if you read the case for Mars, it discusses I believe, transitioning to that, starting with round-trip missions with stays on Mars of 1.5 years, and then stays on Mars of 4 years and 6 years, and then people simply staying. Look, from if you use when you plan Mars missions, people adopt what are called figures of merit. And in contrast to NASA, whose figure of merit was minimum time away from Earth, I think was ridiculous. Because if you want to have minimum time away from Earth, the correct answer is don't leave. The figure of merit we adopted when doing Mars Direct was person days on Mars divided by tons in low Earth orbit. Person days on Mars being a rough measure of the productivity of the mission, and tons in low Earth orbit, or mass in low Earth orbit, being a measure of the cost. So benefit divided by cost. Well, if you apply that metric, the correct answer is the one-way mission. That is the ultimate correct answer, because first of all, you lose all the mass of the return mission, and you get a much longer stay on Mars. You get the entire remainder of the life of the crew, plus the lifetimes of their children, if they happen, and so forth. And the but when we were designing Mars Direct, we were designing a mission for sale to NASA and therefore to the American political class. And it was inconceivable that we could get them to get their minds around a one-way mission. It was their entire vision of a Mars mission is you go to Mars, you explore, you return, and you have your ticker tape parade. Okay, and perhaps you have a series of missions, perhaps you build an outpost, but that's in the future. And so that's how it is. Now, it's quite true that, now my understanding of the one-way mission, both as I would think of it and what I understand Mars One thinks of it, is this is not a suicide mission, this is a colonization mission. Okay. That is, it's not that we're going to Mars one way and spend 2 years on the surface and take suicide pills. We're going to Mars one way in order to live there and settle there and build a new society there. That's the purpose of going to Mars one way. And not simply to explore for a finite amount of time and check out. Now, now if you're going to do that, the one-way mission has to be conceived of as the wedge end of a settlement program. That you follow the first mission immediately with additional one-way missions. You back up the first crew with more people, more equipment, more supplies, more of everything. Okay. In other words, it's not a raid; it's an invasion, and that's how it has to be done. So that the way you think, it's the Normandy Beach approach. You go there, you hit the beach, and then you send reinforcements. You take the beach, you take France, you take the continent, and you're there to stay. So you have to conceive of it in terms of logistics. You have to conceive of building the one-way mission not as, you see, if you were just doing an expedition, you could think of, for instance, the financial planning of this is how do we raise enough money to do an expedition? Whereas here you have to think of it in terms of how do you build the organization that can continue to supply the money to send an ongoing stream of follow-up missions and supply missions and everything else needed to continually reinforce and build this thing up. Okay, so that's what I believe. Part of the idea of building the Mars Society was we would do an initial project, use that to gain the credibility to do more advanced projects, that is to raise an order of magnitude more funds, to do much more ambitious projects, and then those would lead to an order of magnitude more. That's why we built the Arctic Research Station. That's one of the reasons for Mars Arctic 365. Aside from the science, aside from the experience, it is to gain the credibility and the worldwide presence required to mobilize the funds and resources, personal, technical, otherwise, to do ever more ambitious missions. And I think that's how Mars One needs to conceive its program.
So Robert, if you wouldn't be designing the mission for NASA, but for yourself or for a private organization at that time, would it have ended up a return mission or a mission of permanent settlement?
Well, it would certainly end up as a mission of permanent settlement sooner rather than later. Now, the question is whether you design a Mars mission without return capability, other than, you can easily design into the mission a free return trajectory that if it doesn't land on Mars, does come back. That can be done, and should be done. Involves taking a 6-month transit out to Mars, and then swinging around and getting to Earth 2 years after you left. You can have a free return. But to go to Mars without an ascent vehicle is an interesting proposition. I think frankly, it depends on the amount of money you have. If I had all the money that the U.S. government has, I would design it with an ascent vehicle. If I had to do this on a narrow funding base, that I had to construct privately, I might well have designed it as a one-way landing mission, provided that you build into it a financial and logistical infrastructure required to, when you send those people to Mars, you already know you have the base in place, that is the financial and organizational base in place on Earth to continue to send reinforcements to back to Mars.
Yeah, that's really interesting, because I don't think we should talk about this for a long time, but if I had all the money of the US government, I would just send bigger crews to Mars without even sending you. But that's, I look forward to discussing that in more detail, but let's, I think we open it up to questions from the room.
Yeah. So, now I will moderate your questions with Stefan Günther here. I will go to you with a microphone and you can speak to him. So, who has a question? Here. Robert Vogelben. Yep.
Hi, so far I know one of the biggest problems during long-flight space travels is shielding the crew from the deadly cosmic radiation. How do you plan to do this?
And cosmic radiation. Okay, there's two kinds of radiation of concern in interplanetary space. That is, we don't have to trap radiation at Van Allen belts, but we have two other kinds, which are solar flares and cosmic rays. The solar flares are events that occur unpredictably. You might have a large one about once a year. You'll have more of them during solar max and solar min, but that's a probabilistic difference. You could, in principle, have one anytime. And these could deliver 1,000 rem or more to an unshielded astronaut. 100 rems is a sievert, so it could deliver 10 sieverts, 20 sieverts to an unshielded astronaut within hours, and that would be a fatal dose. However, the solar flares are made they come from the sun, and they're made of protons with energies on the order of 1 million electron volts, and that kind of stuff can be stopped by 12 centimeters of water, or things that from a nuclear point of view are essentially the same thing as water, such as food or wastes. And you can pack that much material around a solar flare storm shelter, for instance, a central area on the ship, which uses your food storage area or pantry, and you could, if a solar flare happens, you go in there, you're packed pretty tight for a few hours, but it ends, you come out, and that's how you're protected against solar flares. If you're doing a Mars mission, presumably you have enough supplies on the ship to give you the mass to do shielding against a solar flare. Once you're on Mars, the atmosphere will actually shield you against solar flares. As thin as the atmosphere is, if you're on the surface of Mars at datum, that is the equivalent of sea level on Mars, and you look straight up, there is the equivalent of 16 grams of water per square centimeter directly overhead, but most particles are not going to come straight down from the zenith. They're going to come in obliquely through the sky, and if you average over the 2 pi steradians of the hemisphere above you, that's the equivalent of around 60 centimeters of water of shielding. And so on the surface of Mars, you actually are shielded against solar flares adequately. Now, the other kind of radiation is the cosmic rays. Now, these are particles, they don't come from the sun, they come from interstellar space. The process that creates them is actually not completely understood, but they certainly are there, and they're particles that are coming in with energies not of 1 million volts per particle, but of 1 billion volts per particle. So while you're in transit, certainly, you do not have the mass to provide shielding against them. However, the magnitude of the dose is not that great. It's about 60 rem, or 0.6 sieverts, for every year you're in interplanetary space. And so on a 6-month transit out to Mars, it's 30 rem. 30 rem would represent about 0.5% of risk of getting cancer at some point later in your life, assuming the linear hypothesis, which scales down risk from big doses to small doses, is correct. Actually, it's unlikely to be correct. It's probably extremely overestimates the risk, but that's the metric that we use. So that's a 0.5% risk, which is equivalent risk to sustaining a heavy smoking habit over the same period of time. Now, when you're on Mars, first of all, that dose is by about a factor 2, primarily because Mars is under you when that shields out half the sky. You also can get some shielding from the atmosphere, not that much, but some. That's if you're on the surface of Mars. Now, if you want to reduce that further, you have a lot of mass available to do it. You could put sandbags on the roof of your hat, for example, so that all the time you're inside, you have adequate shielding and that dose is cut out. And so you only get this larger dose when you're on EVA. So the long and the short of it is you can probably cut that dose count to perhaps 10 rem a year, a tenth of a C per year while you're on the surface of Mars. Now that is a higher dose than, for instance, regulatory agencies in the United States set for nuclear power plant workers. The occupational limit for a nuclear power plant worker is 5 rems a year. But that's a regulatory limit. It's not a true safety limit. Regulators have the freedom to simply set a low enough level. They say, well, there'll be absolutely no risk to anyone if we set it at that level, so we'll set it at that level. On Mars, that dose is going to be a little higher, so you'll have slightly higher risk from radiation than you would if you were a nuclear power plant worker on Earth. On the other hand, you'll have less risk of a terrorist or other, or of getting a disease. I live in Colorado. Every time I go to Europe, I get sick because I live in an area that is not terribly densely populated, and in Europe there's a much larger population, and it's more cosmopolitan. People coming from all over the world, so there's a lot more germs around. Well, there'll be a lot less germs on Mars, so anyway, there'll be some risk, but really it's not, and it's overblown.
Thank you, Robert.
I think, Robert, a really brief comment on that. Do you agree with me that radiation is the biggest perceived risk in the media and maybe one of the smallest risks for the actual mission?
Yes, that's correct.
Okay, any further questions, please?
One behind you.
Yeah.
Hello, my name is Roel from Belgium. You told us that at the NASA Society you had some experiments with people who have been locked up during several months or even a year. Can you tell us something about psychological phenomena that occur at that moment? How do people live together in an isolated space? How do they react? Can you tell us something about that?
Could you summarize the question? I didn't hear it clearly. Maybe somebody...
Yeah, about the psychological problems that can occur when people live together during several months in an insulated room. You told us that NASA Society has done some experiments in the desert, that people are living in a small isolated room for several months, far from the world. And how do they react to that?
Okay, I believe the question is what observations have we made of the psychological issues associated with isolation? Would that be a fair summary of the question?
Yes.
Okay. Mars Society in its analog stations, it's done about 120 two-week missions. We've done about 10 one-month missions and 1 4-month mission. Okay, so that's the base that we work on. Very large number of two-week missions, a smaller number of 1-month missions, and then 1 4-month mission. Now, general observations are, there are certain human factors problems that would not come out in a 2-week mission in general, but would come out in a longer mission. So in that sense, the base is limited. However, first of all, there are a lot of human factor problems that can come out in 2 weeks or frankly 4 days. Some of the worst problems of incompatibility of the crew can certainly come out in 2 weeks. Now, let me say this. In order to drive these problems out into the open on a crew, you have to be tasking the crew to do something. This is why I'm not that enthusiastic about isolation experiments like Mars 500 that was done in Moscow a couple of years ago, where they had a crew sitting in a room for 500 days, playing chess and reading books, because that does not duplicate the stress of a Mars mission. When you have a crew out in the field attempting to conduct science, putting up with all the difficulties that the field environment involves, and the frustrations of dealing with equipment that breaks down just as you're about to launch your EVA, and dealing with perhaps competition, where one scientist wants to do his program and the other one wants to do her program, and why does she always get priority? And if we don't launch my experiment now, I'm not going to get my results, and so forth. And you really have to be, and that's one of the importance of human factors research, not in isolation chambers, but in field exploration environments. Another observation is this. Look, we've had all kinds of crews. We've had all American crews, we've had all German crews, we've had all Hungarian crews, and so forth. We've had mixed international crews. We've had crews all men, all women, half and half, 60-40, you name it. We've had crews that were mostly people over 50, and we've had crews that were all under 25, and we've had crews with mixed age distributions. We've had male commanders and female commanders. You name it, we've done it. And what I would say is this, is that almost any of these abstract groups can work. Some do work a bit better than others in general. But you really have to test the crew. The people are individuals, and for instance, you take the issue of an international crew versus a national crew. International crews can work very well, provided the people on it are internationalists. The national crews can work very well and are helped if the people on it are flag patriots and of their country. But you wouldn't want to have an international crew composed half and half of flag patriots of 2 different countries. In other words, probably the worst crew I could think of for a Mars mission would be the one that Carl Sagan proposed back in the 80s of a crew drawn half and half of US and Soviet astronauts and cosmonauts. That is a crew drawn half and half, recruited from, military fighter pilots of people who are trained to want to kill each other. And on the other hand, a crew entirely of astronauts or cosmonauts would have worked. Or if you want an international crew, you'd be, drawn from university professors who are cosmopolitan in outlook and are committed to this sort of international ideal of humanity all working together. That could work very well. One thing also is this, is that you can recruit people based on their resumes, and you say this would be a good person and that would be a good person, and this is a good mix of skills. Skills can be identified that you need to have the right mixture to compose a crew. So many scientists, so many mechanics, so forth. To know whether they will work well together, you have to put them together. We've had situations, because we've had certainly a number of people who've been on more than one of our expeditions, and we've had people who were terrific crew members in one expedition, but were horrible crew members in another. And the reason is because there was another person on the crew that they didn't mix well with. The chemistry wasn't right. So I believe that you want to select a crew for Mars. You will want to have several of these Mars analog stations, and we'll say, okay, do our best job of selecting, well, here are 6 people that should work well together. We'll put them here, that's crew A. Here's 6 people that should work together. We'll put them over there, that's crew B. And we'll task them to conduct a sustained program of field exploration for 6 months or a year in the Arctic or some other Mars-like environment. And we'll see which one works together as a team. This is a team sport. Individual talent is required, but it's not enough. You've got to pick a crew that works well together.
Thank you very much, Robert. Next question.
Robert, in 1991, there was this Biosphere 2 mission, which was actually a failure. Did you take that data and use it for your experiments as well?
Well, Biosphere 2, I don't know if you'd call it a failure. If you say, here is a practice mission and we expect it to go off without a hitch, then yes, failure. If you say, here is a practice mission and we're going to want to see where the problems are, then you say this was a useful experiment. Now, of course, Biosphere 2 was not flight-like in any way. It was much bigger and fancier than anything anyone would ever send to Mars. It was in the first, 30, 40, 50 years of effort, as opposed to our stations, which you've probably seen, which are flight-like. Biosphere was this complex, different biomes. One representing a coral reef and another representing a rainforest. We're not going to be sending rainforests and coral reefs to Mars for some time. The greenhouses that we send to Mars are going to be farms. And every square meter then is going to be precious for its productivity. Now, one thing that was very evident in Biosphere 2, because we had a conference in Boulder while that experiment was going on. We had a video telecom. It wasn't Skype, it was a predecessor kind of system. And they all looked very tired. They were actually severely overworked maintaining this thing. Now, part of that, once again, is they were trying to maintain, I believe, 7 different biomes, at least 6 of which were unnecessary for their survival. And, so crews on Mars are not going to need to have people from Earth think of ways to consume their time. This is something that we have found in our field expeditions as well. Time is a precious resource. We don't need to create ways to occupy the time of the crew, such as maintaining coral reefs and rainforests. I mean, if someone want to have a little terrarium for fun, fine, but we don't need make work for that. And we don't need it in our Mars Arctic station either. The crew's time is heavily consumed with dealing with things they deal with, and to the extent they can get time off, really valuable. The main problem on Mars is not going to be boredom, it's going to be overwork. And so the lesson of Biosphere 2, as far as I'm concerned, is first of all, the system needs to be simpler, smaller, and minimize the work burden from the crew.
Okay, thanks, Robert. We have time for 2 more questions. Okay, first row.
My understanding is that my understanding is that we are going to have a very wide range of parameters to decide the suitability of a specific team. So in other words, not just the skills, but also psychometrically matching the people with each other. Have you done it like that in your experiments so far? It's really psychometric, being almost more important than the skills, because we will be taught the skills that we need.
Well, the skills are quite important, but they're easily selected for. You easily determine who has a given skill. But the sociometric, if you will, or the character of the people is harder to determine. And that is why I'm a strong advocate of these Mars analog stations. As I say, we've had over 130 expeditions, 6 people each. That is about 800 people that we have had as member of one crew or another, and so certainly there's been a wide range of character types. Really, for instance, some people who are very successful and very skillful are hyper-competitive. Okay? And certainly that was one of the character traits of the Apollo astronauts. I know some of the Apollo astronauts, including some that were on the same crew with each other, and they don't talk to each other today. They hate each other because one of them achieved greater prominence than another, and the other resents that. So you don't want to have hyper-competitive people in the crew in general. You want to have people that can work well with others. Now, you need to have leadership personalities. The crew generally needs a commander, because you can't have endless disputes over what's done. So the commander should have a consultative leadership style. But I would say one of the most important character traits that you want to have in a Mars crew, members of Mars crew, is a sense of humor. I'm not kidding. Because things that happen are frustrating, and you need to have people who can take it in stride, who can sort of laugh at adversity and shrug it off, view it perhaps with a certain amount of irony, but deal with it instead of getting all uptight. So these sorts of character traits, are necessary. You really want to have a one for all and all for one kind of crew, as opposed to crews of people who are each trying to become more famous than the other one or something, or to simply have a satisfaction showing that they're better than another one. Now watch out for that.
Okay, great, thanks, Robert. And one final question.
So I'm more interested in what the people will be doing once they're on Mars. So will they be living in capsules? Will they be terraforming? Will they stay on the surface? Obviously, if they go into the ground, there's a possibility of liquid water, I've heard. What exactly will they be doing once they're on Mars?
Okay, that's a great question. All right, what are they doing on Mars? we're going to explore, we're going to prospect, and we're going to develop. That is, certainly, there are scientific questions of great interest to humanity on Earth that once we're on Mars, we're going to be able to resolve, such as the questions of whether life can be on Mars and how planetary yet and what characteristic types it developed into. And we'll do that, but this is a settled mission, and therefore, perhaps even a higher priority than that, will be to, first of all, prospect for resources. We'll want to know where there is, supplies of water, which could be in the form, well, first of all, there is water in the soil. Even at the equator, is 5% water in the Martian soil, and at higher latitudes, the concentration can go as high as 60%. So one way to get water on Mars would be to simply bake it out of the soil. But if you could find deposits of ice, that's better. If you could find liquid water underground, that's better still. So, for instance, prospecting for underground liquid water within drilling distance of the surface, and then drilling for it and acquiring that water and perhaps setting a source of geothermal power. And so locating places where water and geothermal power is available would be an important thing to do. Also looking for mineral ore. This, by the way, is one of the reasons why Mars is a much more promising destination for colonization than the Moon. There's no possibility of liquid water on the Moon or geothermal power on the Moon. And even water in frozen form in the soil is only parts per million, except in 40 Kelvin craters at the pole, and there's no carbon on them. So you can't grow crops on them out of native material. On Mars, we want to build greenhouses and grow crops. Now, initial greenhouses will probably bring as inflatables from Earth, but we're going to create facilities to make either glass or plastics on Mars, both of which are possible, because of course there's silicon oxide on Mars, and there's also carbon and hydrogen, so we can make plastics. So we'll be wanting to build facilities, to make all kinds of structural materials. Another thing you can make readily on Mars is steel, because Mars is extremely rich in iron oxide. And the iron oxide can produce iron using either hydrogen you get from water or using carbon monoxide that you get from breaking down Martian carbon dioxide into carbon monoxide and hydrogen. So we'll want to be creating facilities to make use of Martian resources. That's, I guess, the most general term. Martian protective force, we make use of Martian resources to make fuel and oxygen for each trip. In this mission, we're going to make fuel and oxygen for use on Mars. There's also chemical fuels represent concentrated portable power, whether you have a nuclear power plant or solar panels at the base. You can accumulate power and turn it into portable form by making chemical fuels, both to power vehicles or to power drilling rigs at a distance from the base, and so forth. So we're going to make fuel and oxygen. We're not going to acquire stockpiles of water, drinking purposes and all kinds of other purposes. We're going to make steel, we're going to make plastic, we're going to make glass, we're going to make things out of steel, plastic. We're going to make greenhouses, we're going to make habitations to expand the habitable areas of the base. We're going to want to locate supplies of concentrated mineral water, copper. Copper is geochemically, this may surprise you, it's geochemically one of the rarest elements on Earth. It's very rare. And yet, human societies have used it since Neolithic times. And of course, we've got Bronze Age before had an iron in. And how is that possible? Well, it's possible because nature has processes that concentrate copper atoms into copper ores that are concentrated and therefore readily apparent to people, those with low technological abilities. And and so it becomes a useful resource. So we're going to want to find locations on Mars where natural processes, volcanic processes, possibly biological processes, have concentrated various elements of concentrated ore, and identify them for exploitation and purpose to use them. So this is what they're going to be doing. They're going to be building up a settlement. Now, I think also that in the process of doing this, given that the Mars colonists in general would be technologically adept people and be in this challenging environment, and they will not have a large bureaucracy telling them what they can do and they can't do and demand 2 years of work and try to experiment. I think this is going to be a very inventive colony, and I'm sure that the process of meeting its challenges of life on Mars, that colonists can come up with inventions that can be licensed on as patents, and I think that that is one of the financial streams the colony will create for itself, will allow it to continue to be funded and to bring up more people and more users.
Okay, great. Thank you very much, Robert. Thank you very much. Here at that point, we have to conclude our questionnaire. Thanks for the great questions, and a big thanks to you, Robert, on the other side of the Atlantic. Have a great day. It was very informative, inspiring. Listen to you, and thanks a lot. Have a great day.
All right, thank you. I want to say one thing, because I left one thing out of that last question.
Okay.
There's one more thing those colonists are going to be doing, and that is raising the next generation, the first generation born on Mars.
Okay, thanks a lot, Robert.
Thank you.
Take
All
care.
right, thank you.
Bye. Okay, now let's see how we go further. Bas, I think you have something to say too, or would be great. Thanks a lot.
So, first of all, welcome everyone, and for me it's really a pleasure to see so many people, many of whom have probably applied. Can I ask who is either already applied or is in the process of applying for the Mars One mission? Wow, that's really great. It's really nice to meet all you guys. I would also like to take this opportunity to thank Rob. He thanked a lot of people, but I think we really owe Rob a big thanks for organizing this. And well, it's a pleasure to be here and talk to everyone. I think most of you have already seen a number of presentations by me, so I'm going to talk really briefly and then open it up for questions. And I think two things that I would like to talk about are explain in a little bit more detail how Mars One came to exist, because I was still a really brief version, and you guys, as wanting to be part of this, are probably interested in hearing a little bit more detail on that. And I will explain you, which is one of the most frequently asked questions, why are we selecting people from the general audience and not from existing pools of astronauts? So I think those are two things that are important questions, and if you think, well, we heard that all, then suggest something else, but otherwise I will start talking about this. So, how did Mars One came to exist? Well, the thing you probably heard before is when I was 16 years ago, when I was about 20 years old, I saw the images of the first Mars rover, the Sojourner rover. They were on TV when that rover landed, and for some reason that I really cannot explain, I wanted to go to Mars. But to you that's no surprise, but to a lot of people that's something really strange. Why do you want to go to Mars? And for me it's actually really difficult to explain. It's to go there, to explore a new world, to build a new place for humans to live, but why? It's very difficult to explain. It's almost like love, where I have a girlfriend, and I like her. If I have to tell people why I like her, say, well, she's smart and she's funny and she does a lot of sports. I like that. But then there's millions of women out there that are funny and smart and do a lot of sports. I'm not in love with them, I'm in love with my girlfriend. And you know, it's almost like that. It's difficult to put your finger on it, but I just want to do this. And I just love my girlfriend. And that's I think that's at least how I feel about Mars. So I had this feeling that I had to do this, and I'm not an American citizen, so I knew that my chances of going through some kind of NASA process ending up on Mars were extremely slim. The European Space Agency, especially back then, was not very seriously considering Mars, so that was not a serious option either. So I thought the only way I'm going to Mars is if I organize my own mission. So I just started researching. I read Robert's book, and I read a lot of other books and papers and research about what technology is available, how did other people organize their missions. Of course, I looked at the big original NASA proposals, the $500 billion proposal with a huge Battlestar Galactica flying to Mars and back. And what I started doing was really, whatever I read, I found, why are all these people so desperate about going back? Because if you remove the return mission from the equation, then suddenly you don't need that huge ship here on Earth. You don't need the big launch vehicle, you don't need the big landing system. There's so many things that you don't need if you talk about a mission of permanent settlement. And keeping humans alive on Mars it's very hard. And the life support system and the suits, all the things that have to stay operational when you're on Mars, that's no easy thing. But it's much less complex than trying to build Cape Canaveral on Mars, because that's what you're trying to do, build a launch base on Mars to get humans back. And that's, in my opinion, if we try that approach, it's going to take a very, very long time. So I started working on that, but I was also studying. I was studying mechanical engineering at the time at Twente University. So at some point I didn't have time to work on it anymore, and I graduated and I started working at Delft University, and I got the opportunity to, I'm skipping one really important step. When I graduated on artificial gravity, an artificial gravity tether deployer, and during my thesis, I investigated artificial gravity. I spoke at the Dutch Mars Society, at a small meeting of the Dutch Mars Society about artificial gravity and how long should your cable be, how fast would you rotate. And there I met Arno, he was the co-founder of Mars One, which is of course a very big coincidence because how many people graduate in artificial gravity? So I met Arno there. I didn't really get in touch with him, we weren't friends or anything. Then in 2006, there was an opportunity for me to join in the Moon Mars Habitat Design Workshop at ESA, the European Space Agency, and I submitted my proposal, my resume, so to say, to participate. And I was there, and Arno was there too, so that was a big surprise for me because I hadn't seen Arno in a couple of years. And we talked there again about missions to Mars, and of course we worked on a Mars habitat design. And I became fascinated again about actually going there, so I looked at all my old research, which was still on my computer, and I built on that. I used some of the new developments that were going on. SpaceX was one of the companies that had started since then. Inflatable technologies were emerging. So I researched it again, but I had a job also, so I had to at some point again let go of it and do my job. Then I was interviewed at for my previous company. I had a wind energy company before this. I was interviewed by a journalist, and she asked me, what would you like to do after Applicants Power, the name of my wind energy company? What would you like to do after that? And I had never thought about that because I was working 70 or 80 hours per week trying to build this company. So I sat for a moment and I said, well, if I become a billionaire of this company, I would like to organize my own mission to Mars. So the journalist was really interested. I said, oh, please don't put that in your story because we will never get an investor if you do. Again, it triggered my fascination, but only a little bit, and I forgot about it quickly. But this journalist sent me an email in January 2011 saying, hey, there's two guys stealing your idea. And there were two scientists from the US who wrote a paper about the one-way mission to Mars. Of course, it's not my idea because lots of people have thought about one-way missions to Mars. But she wrote me that email, and then I thought, you know what? I'm going to look into it again. And I invited Arno over because we were in touch by then a lot more. And for a whole day, we looked at the last piece of the puzzle, which was, in our opinion, how do you finance it? And we saw the what finally turned it all around was we saw the pictures of the revenue numbers of the Olympic Games. The London Olympics have had revenues of more than $4 billion in 3 weeks of broadcasting. So it's more than $1 billion per week just because the world is interested. Because that's the only thing they're selling is the world being interested. And that really didn't mean anything to us. Because I'm a mechanical engineer, Arno is a physicist. We thought, well, that's a lot of money. Could we do something with it? So we contacted Paul Römer, who's the inventor of Big Brother. And I wrote him a really brief LinkedIn message. I didn't have his phone number, so I wrote him a really brief LinkedIn message. Would you be interested in discussing the media value of a one-way mission to Mars? Regards, Paul. And he replied to that. He said, sure, come on over and let's talk about it. And I explained to him our plan together with Arno. And we said, well, you know, Olympics, these revenue numbers, could we do something similar? And Paul Römer said, if this is really technically possible, if you can really do this, then this is going to be the biggest story of all times. This is the story that people will watch for 50 years. Humanity moving out of its cradle to the next planet and staying there. And that's basically how it all began. And look at all the coincidences. I could never have met Arno, and I could never have started Mars One without Arno, because he has all the space contacts. He still works 4 days a week at the European Space Agency. And if Paul Römer would have said no to our email, would I have sent another one? And what's the chance of doing your masterthesis on artificial gravity? And what's the chance of meeting Arno in that first meeting? You know, all these little odds, all these things coming together. Otherwise, I wouldn't have started Mars One. So it's really a lot of luck or determination. It's always a combination of the two, but certainly a lot of luck involved too. So that's a little bit of history on Mars One. I talked a little bit longer than I planned, so I'll stay really brief about the bit. Why don't we select from the pool of existing astronauts? And there's a really simple answer for that. Actually, the question was asked to me in the car by Pam. It's really a question that pops up a lot. And the answer is, astronaut is it's not really a job description, it's a job title. So it's like professor. And if you have a question about nuclear physics, you're not going to ask a history professor, you're going to ask a physics professor for the answer. And saying, well, why don't you send astronauts? It's actually almost the same as asking a physics question to a history professor. And you know, the history professor was chosen for his knowledge of history. And the astronauts that we are looking for are not chosen for the same tasks that all the astronauts that exist today are selected for, because nobody ever selected an astronaut to live on Mars for the rest of his life. And we want people, Robert talked about it already, we want people who can work very well in groups. And you need certain skills. We can teach you those skills. You will need to have the ability to learn things quickly, because we have only 7 years to teach you how to repair anything and anyone that breaks, and to grow your own food. It's a lot of things to learn, but it's possible. But the most important thing is, as Robert also said, how do you maintain your group on Mars? How do you cooperate to make this a success? Because you can't do it alone. No matter how good your 4 individuals are, if they don't work as a team, they're not going to make it. And you might have people with half the skills. If they work well together, they are going to do a really good job. And astronauts now, they have subtitles like mission commander or pilot or mission specialist or payload specialist or tourist, actually. And are we going to take a space tourist to go to Mars because he was in space once? Of course not. We need people that we first we will select people whom we believe that they will be able to do that job, and then we will test them extensively. So in the 7 years that people are training, they will spend each year a undetermined period in a copy of the Mars outpost here on Earth, doing all the things that they will do on Mars with the team that they might go to Mars with, to see, are these the right people, is this the right team for the job. I think that's two things that I have time to talk about, and I really look forward to answering all your questions, and I'll be here until 7:30, so if you don't get to ask your question now, you can always ask it later, and I'll try to keep my answers brief so I can answer as many questions as possible. Thank you very much.
Great, thank you very much. We just decided to make a short break, 10 minutes, so you have a chance to also get some fresh air, and we open the doors and relax for the next what comes up now. Thanks a lot.
Down here.
Oh yeah, I will stay seated if that's okay. If I can suggest, because we only have 30 minutes left, right? Do we really have to leave at 5 exactly?
Not exactly, but we should have a whole time.
So if you have a question, please ask it really concisely. Don't give the introduction and the summary. Just bang the question, and I will also try to keep my answers below 1 minute, so we can try to do something like 20 questions in as little time as possible.
So first. So, who has a question? Okay.
Hi. What do you think a Mars colony's relationship would be with Earth kind of more long term? What do you think would be some of the social and political challenges of that?
I think that when humans land on Earth, it will really have a much bigger impact on. When humans land on Mars, it will have a much bigger impact than a lot of people realize. It will, was mentioned in the documentary by a few people, it will really change our understanding also of our own planet. I think that's the most important thing that the Mars colony can give back to Earth, is to have us experience what that means. And I hope that as soon as possible the Mars colony will be independent, they will need us for a long time for computers, for instance, but you don't really need a computer to survive. So I would hope that as soon as possible they could survive in the barest survival mode without any supply missions from Earth. I think that would be a really grand achievement.
Okay, we come to the next question.
Thank you. So far I understood you will finance the mission by selling the media rights, like the Olympics. I'm a journalist myself, so I compare it to the Apollo mission. Apollo 11 was a big thing. And after that, after 2 more missions, nobody was interested. And if the accident at Apollo 11 did not happen, the interest of the people would wane. So with your mission, I see 2 highlights. The launch, of course, and the landing of the Mars. So how do you plan to keep the interest in the people of Earth into your mission for a long time?
Well, first of all, the media aspects are not the only way of financing what we want to do. So there's sponsorships which will be interesting for a longer time, but more importantly, maybe if we organize this mission, we pay for all this hardware, we will make agreements where we become co-owner of the intellectual property. So for miniaturized medical equipment, for recycling, for solar panels, and Mars One will get revenues from those intellectual property rights, especially in the somewhat longer run when, I agree with you completely, the media revenues will of course peak and then go down. Another thing is, people on Earth want this to happen, and there's a lot of geeks out there on Earth. I think many of us are probably, to some extent, geeks. and people will want to pay something to make this possible. So, especially once everybody knows about this and this is happening, I think a lot of people will make a small contribution just to make this happen faster. But on the media aspects, very briefly, because of my 1 minute constraint, don't forget that Apollo was a repetition of a number of identical missions. And what we will be doing is taking humanity's next step. And that's a never-ending story. It's not just planting a flag, it's going there, solving problems, building a settlement, the second crew coming, how do those two crews interact? What if a baby is born on Mars? A marriage happens on Mars. These are all things, they will become our TV friends, and we will want to follow the stories of our TV friends, just like people have been watching The Bold and the Beautiful for 50 years.
Okay, thank you. Thank you. I have a question from Twitter. It's from Julia. Should the first 4 astronauts on Mars work around the clock?
Well, they will be prepared to handle all the tasks that they will get on Earth. So we'll build a copy of the Mars settlement here on Earth, and the crews will train it in their crew every year. And in these settlements, we will actually give them the worst kind, the worst kinds of conditions. So everything will go wrong. And the toilet will break. That's actually one of the worst things that happen. The toilet will break, your plants will die, your life support system will fail. Everything will be going wrong, and at the same time. And only crews that come through these challenges in a good way, they will be the ones that are eligible to go to Mars. So on Mars, it should be relatively, from the workload point of view, easy compared to what you have to do on Earth. But on Mars, of course, there's the aspect of knowing that you can't just step outside if your oxygen inside is running out because your life support system is failing. So I think that psychological issue will be a larger factor. They will be very busy, don't get me wrong. Just growing your own food will take, especially for the first crew, at least half their time. So a lot to do.
Should they work in shifts or?
No, I don't. There will always be something to do because you can't just say, no, my 8-hour day is over, I'm not going to maintain the life support system tonight. But we will make sure that the systems are designed in such a way that they have a reasonable workload.
Okay, thank you. Next question?
Can you tell us how many candidates have finished their application at the moment? Because on the website I count about 1,300. I know that a lot of people choose not to go public, but can you tell something about that?
Yeah, we don't disclose the numbers, and I'll explain the reasoning for that. So, when people apply, the first thing, most of you know that, the first thing you find is you have to fill in your details, and then you get a payment link. And quite a few people have, at that moment, decided not to pay. And we have considered, when we made the announcement of the 78,000 people, which includes those people that did not pay, we've considered what number are we going to tell? Are we going to tell the number of people that paid or finished? But we feel that people who, when they found out that they had to pay, if you then decide not to do it, are you not interested to go to Mars? Or do you just think, well, I actually think it's $35. I don't think I'm the right material. Maybe I don't continue. And I feel that everybody who at first thought had the idea, wow, I want to do this. These are all aspiring Martians, and the fact that they don't feel that they want to pay for it doesn't make them any less so. So besides there's more people that finish their profiles than the ones that you can see online, because there's also the private profiles. And there's a very large number of people who are in between, so who are working on their profiles. I've been in the car who did already apply but didn't finish her profile yet because she was still thinking about it. So there's a lot of people like that who maybe they want to make the perfect movie or they want to have the perfect answers to the questions. I think there's quite a few people like that.
Okay, thank you. Next.
Zubrin told us how to get iron using the Martian soil and extracting the iron with hydrogen. Are there ways to extract other elements you need on a Mars, on a settlement, that you know that you can use this in the Mars 1 mission?
Well, the design that we have taken has always been about simplifying everything we can. So in our plan there's no need for rather complex procedures like extracting iron from the soil, because that's really something that takes already advanced capabilities on Mars. The only things we want to take are water, which you can simply evaporate from the soil and then liquefy again. From the water you can make oxygen and hydrogen. From the Martian atmosphere we will take nitrogen. And these are the most important components. All the other components we don't want to rely on. There's many things that you can do. Plastics would be very interesting, because I would be very eager to start producing solar panels where you have the top and bottom layer of the solar panel produced on Mars, and only the thin film of the actual silicon is brought from Earth. Making habitable volume, but in the simplest way possible, for instance by bringing an airtight bladder from Earth and building with Martian bricks, so molten sand for instance, a structure around it. I think success lies for something like this in simplicity. You go back to the Stone Age.
Thank you. Another question?
Okay, so this is about risks. So can you please tell us when do you expect the most important risks in this project to be encountered, and which are these?
That's a really interesting question, and the logical answers would be the landing on Mars, keeping the life support operational. But I don't think that these will be the things that will cause the real problems. I don't know if everybody knows here what happened in the Apollo 1. With the Apollo 1 crew, they died in an accident in a pressurization test of the capsule. There was no launch plan, nothing drastic was going to happen. They were just going to sit in there, they were going to pressurize the capsule, and that was it. And on the inside there was a fire, and they couldn't open the hatch because there was pressure inside. So I think the big risks is in the things that, despite of all the testing and all the preparations and all the analysis that we will do in advance, the risk will be in the really small things that we didn't think of because they seem to be such small things. Other than that, I think the big challenge would be building suits that allow you guys to spend as much time on the surface as you want. Because suits are really one of the biggest technical challenges. To build a suit that can go for 4-6 years, every 3 days outside, that's a big challenge.
Okay, thank you.
I have a question about the next stage, which is coming, reviewing our applications. How many people will review them, and how it will look like? I mean, for example, someone can like my application, someone else will say that it's average or it's not interesting. And if I'm lucky, it will be reviewed by someone who liked it or not. How it will? Can you tell something more than reading frequently asked questions?
Yeah, only a very little bit, because that's really Norbert's area of expertise, and I'm spending only a very small amount of time on that. So that's why you can buy me drinks, you can won't have any influence. So you might as well not do that. So a very important thing is, first of all, we'll have at least 3 people look at applications to make sure that there's, if one person is negative, then there can be still 2 positive people, so you can still continue. But what's very important to realize is that we'll have multiple rounds. So the people that move on to round number 2 are very likely not the best people, but they are most likely not to be the wrong people, if you understand what I mean. So we'll try to exclude the people who we are almost certain that they are not the right stuff. Of course, it's difficult, because you only gave us so much information, we only asked you for so much information, so we will make mistakes there, that's beyond doubt. It's impossible to make no mistakes in an online application, but we'll try to make sure that everybody who has a chance of being the right stuff will move on to round number 2.
Okay.
The success of every mission is redundance. I don't see a lot of redundancy in 4 people. I'm a surgeon and I know how easy a person can die. Have you considered, I know I'm bleak here, have you considered the possibility that someone actually dies on Mars? And what would happen there?
And we will make sure that all the necessary skills are in 2 people, and that the other 2 people have the backup and not the skills up to the same level as the 2 that are actually trained with skills, but have enough backup skills to also perform a number of those tasks. The good thing, of course, is that every 2 years more people are coming, so we will be growing that group of people with a number of skills. But you're absolutely right, that's yet another risk, I would say, because there are, of course, many risks, and in a mission like this, what we need to do is design a mission where we feel that the risks are acceptable, but that's only us. What you guys will have to decide is you will have to look at those risks when you decide, and when we tell you that you can continue to run number 2 or 3 or 4, and when we offer you a job to train full-time for the mission, you will have to think at any time, do I feel that the risks associated with this mission are worth the reward that I'm getting in return? And one of those risks is losing a crew member over, for instance, a stupid accident. He slips and breaks his neck. That can happen here on Earth, but also on Mars. And then you lack one person with certain skills that you would like to have. But we cannot send crews that are 6 people big, and I don't think that we will manage financially to send 2 crews of 4 in 2023, which I would really like to do, which I would prefer, but I don't think that will be financially possible. So it's up to you to decide if that risk is worth the reward. Well, we'll make sure that the skills are multiple people, so the skill that this person, that skill that's no longer available is available in another person.
Okay, here.
I still have my question about, will there be strong psychometric tests to make sure that every team, to not leave it to chance, but have a better chance of getting very good teams together?
Yeah, Mars One is not an aerospace company, so we're not building rockets, we're not building suits. We do only 2 things. We're going to make sure that this happens, and we'll select the best teams for the job, and we will be selecting teams, so not individuals. Robert talked a little bit about it, but he doesn't know all the details of our program. I'll meet him for the first time in 10 days, although we've talked before on the phone. And a key issue of what we do is first we'll select people who have the right personalities, such that they might fit in one of those teams, but then we'll construct teams together with the people in the teams, because if you don't like each other, then it's probably not a good idea. We'll make these teams in such a way that we and the applicants in the team believe, or the astronauts in the team believe, that they can work together, and then we'll test you. So for 7 years, you'll go in a copy of the outpost, you get all the most crazy situations where we can see, does the team remain a team? And as soon as we see fractures in the bonds in such a team, you're out. And it's not one person that's out, it's probably the whole team. Maybe we can recycle some of the people back into the program, but you'll start from the beginning, because you can't just replace a person in a team. A team made of a perfectly functioning team with 4 really capable individuals. Of 2 of those teams, if you mix them, they might make really terrible teams. Good.
And that means the next 2 will have to keep with the first 4.
Yeah, the teams will also have the opportunity to cooperate, so they will be training also together. And we're training for 7 years, So there's always overlap between the teams. And when there's 12 or 16 people on Mars, then this will become much less important, because then you don't have to talk to one of those guys if you don't like him. But with 4, especially with 4, but even with 8 people, that's not really possible.
Yeah, what kind of organization time between the members are you thinking about? Like on the ISS, with a commander, for example.
And the team will likely have a commander, because that's just the easiest way to do these things, but that's when you leave. But what happens when you're on Mars is really for a very large extent up to you. And we can tell you this is the commander, but if all other 3 don't think that he's the best commander, then why would you listen to those guys on Earth? They're not really your problem. So it's really up to the people on Mars to decide how are they going to make these decisions. And we will put, during the training, we will put some kind of decision process in place that you can use and that you can fall back upon in case of emergency, for instance. But how the colony will be run is really up to the people there, because there's a 40-minute time delay. You can't say, Houston, we have a problem, because by the time that the message arrives in Houston, then the problem might have gotten out of hand.
Okay.
So you seem very, very set on this 2023 date. What is the reason for this date specifically? What happens if there is a delay? Time issues.
When we designed this plan, we visited the aerospace companies that you can see on our website, and we've discussed the plan with them, and we said, okay, we have these requirements, this is the kind of funds that we have in mind, and these are the timelines we have in mind. And with their feedback, we came up with the plan that you finally now see on our website. So the plan as we presented is possible. If things go reasonably well, then the plan that we present is possible. But this is space. Recently a Proton rocket exploded just after leaving the launch pad. The Proton rocket is one of the most flown rockets here on Earth, and it exploded. This can happen, so when our 2018 mission fails, or one of the other missions fail, then we will have a delay in the program. And I think as long as you show that there's enough progress going on in your mission, that doesn't have to be a major problem. So we're set on making 2023 because I want this to happen as soon as possible, and a lot of other people want that too. But if there are delays, then there are delays, and this is something that is not impossible, certainly.
Okay, other questions? Please show me.
As you said, the technology for going to Mars is already here. But when you look at the Apollo missions and when the planning started and when they launched, the systems were a bit outdated. How do you compensate for that from planning in terms of computer systems, shielding, and so forth?
Well, I don't think that shielding or computer issues are something that's going to be developments that are important for our mission. It could be that there's some kind of new rocket technology or inflatable systems, but you can't plan for that. At some point you have to say, okay, this is the design that we're going to, this is going to fly to Mars, and then maybe 2 years later or 4 years later you use the new stuff that's available. But at some point in time you're going to have to set your design and build it, because you also need to test it. So it's always the case that for missions that are planned so long in advance, the end product will contain some technologies that are already outdated. As long as they work, then it's no problem.
Thank you.
So I don't know if you've looked at the specs of the camera of the Curiosity lander, but it's really, I think it's 2005 technology or something like that.
With regard to timing, once again, if you have in the build-up to 2023, if one of the launches fails, what are the odds that financial backing will be lost there and the mission will cease to proceed? Or worse still, if the 2023 launch fails during transit?
So yeah, I'll start with your last point. That will be actually one of the best tested things that we do. So a number of systems will have already flown to Mars and will have landed successfully on Mars before the humans take place in exactly the same landing vehicle. So the landing is the most important one. On the way to Mars, and people have spent so much time in space stations already, it's quite well understood. But of course, a failure in the human mission would be dramatic. However, it also happened in Apollo 1. In the Apollo program, the Apollo 1 crew died and the program was continued. I think as long as you have, as long as people believe that you have a good program in place and there was some kind of accident that was out of your control, then people will accept the failure and support you to try again. And I think the same goes actually for the cargo missions. If you have a cargo mission failure, as long as you can show that you are on the right track, then people will believe that this is something that can be done and that's worth supporting. And the technology to land larger payloads on Mars, which we will need, as compared to, for instance, Curiosity, we need about a factor of 2.5 larger entry mass than this system. That's a new system. It's not a new technology. We will be able to use the same technologies with parachutes, hopefully no skycrane, but parachutes and retro rockets and a heat shield. But the actual system test is, of course, a first. I think that our US supplier for that can do that because they've tried 8 times to land something on Mars and 7 have been successful, and the one that failed was actually not because of this issue but something else. It was not really an entry descent and landing issue. So I think that that this is, in short, I think it's acceptable as long as people believe in what you do.
Okay, thank you. So the last questions, please show me. Okay, just 1, 2, okay, another one. So 3. Okay, 3 last questions.
Do you have exactly plans, technical plans for your mission? What rockets do you use, all the technical stuff, and where can I find it? Because I think a lot of people who are in spaceflight are interested also how you will do it technically.
So we actually yesterday or the day before yesterday we put more information in the timeline. So there's already more information available right now. We don't want to pretend that every system that we have there is already available from a supplier. What we have done is we went to the suppliers, we've presented them our requirements. So for instance, for the life support unit, we want so much water per day, we want these kinds of reliabilities, we want this kind of oxygen production, this kind of oxygen storage. Can you build that? And they've investigated that and returned us with positive answers or modifications to our requirements, after which we've taken them into account. So for each component we've sat at the table with engineers from the major aerospace companies that you can see on our website, and we've discussed what these systems might look like. But for instance, the rover, it might be one big rover that can dig up soil for the radiation protection, that can connect the living unit to the life support unit with a hose for before the humans are there for transportation of the air, and can transport the landers. But it could also be that we separate them into 2 rovers. But our suppliers have said, we don't know exactly what that rover will look like, but all the tasks that you want this rover to perform, they can be integrated in rover systems that fit in your landing system, that fit in the mass budget, and that fit in your financial budget. And some of them are far more advanced. So for instance, Paragon Space Development is already working on the life support systems and the suits. So there we're really talking already about components.
Thank you.
The question that I get asked always is, what if you go bankrupt? What if there isn't any money? What then?
I think that right now, finances are definitely one of the biggest challenges for Mars One. So for us to be able to finance all the conceptual design studies, and especially to finance the first 2016 mission to Mars, is a very big challenge for Mars One. If we fail there, then I think that Mars One has done a very important job of making people acquainted with the idea of, first of all, a private organization might just be a better idea to do this than a space agency, and a mission of permanent settlement might just be a much more feasible concept than a return mission. But what I think you're pointing at is, what if the people are there and we are no longer able to support them? First of all, I think that the chance of that occurring is very small. I think the chance that we won't make that is there. And I think that once we have humans on Mars, then, and all the media experts that I talk to have no doubt at all of them, and I've talked to very many, they have no doubt at all that just the documentaries and the event reporting and the stories that you can tell for Mars, this is something that will grab the world for a very long time. Then there's the intellectual property. But imagine, I truly believe if we succeed in the first crew, then all the other things will be relatively straightforward. Even if all that fails, imagine there are 16 people on Mars and Mars One goes bankrupt. That would mean that every nation of the people that are there needs to pay 10 million per year per person to send supply missions. Not new crews, but supply missions to keep the humans alive, which is less than Holland paid for having André Kuipers in the International Space Station. I think that will definitely be worth it. And even supporters. And imagine that Mars One goes bankrupt. I think that everybody in the world will know about this project, and there will be fundraisers where people will make sure that there's funds to make sure that the people on Mars stay alive.
Thank you. Now the last question.
It was about the same question, so I wondered, this would be a great media spectacle, also 10 years until the year 22, when the first launch will be. Don't you think that when people watch that 24 hours a day, that they will be bored and will be not interested anymore after a few years?
I think that question was already asked some time ago. So, as long as you make sure that the stories that you're telling are interesting, then that won't happen. And it's not going to be 24/7 TV, of course. These are people's lives, and the people on Mars will decide what they want to tell the people on Earth. So if they want a private, the dinner time, for instance, is something where they say that's none of your business, then the cameras go off. So first of all the media people that I talk to, they say this is such an interesting story. Exploration is coded in the human genome. Everybody wants to see how humanity moves forward. And they say people watch this for 50 years. But once again, as long as you have other sources of revenue, it's not at all necessary to have a big audience on the long run. But for especially around the first human mission to Mars, it's a very important part of the financing.
Okay, last
Oh yes, I have a question too, but I was waiting actually for this question because I thought somebody will ask it, but it's very, very important for maybe a lot of people to know, especially for applicants. I'm asking as an applicant, when could we expect more information about if we are in round 2 or not?
That really depends on how many people are still applying in August. We will need quite some time, so I would say you should hear within 3 months if you pass to round number tool or not. However, it's also possible that we might want to ring the doorbell with a camera to see your reaction, and then it might take a little bit longer, but we will know within 3 months.
Okay, thank you very much.